All right, here's what we got. Yesterday, what we did is we said that piecewise functions are functions that consist of multiple pieces. And what do I mean by pieces? I mean something like this and that and that, right? One equation cannot create that in a sense, right? And so we have to have multiple equations, right? And we said that they were separated by different domain values, right? And we looked at that in terms of what the yellow x values are, what the blue x values are, what the green x values are. Everybody good with that? That's kind of where we left, all right? So we said, guys, that the yellow piece went from -8 to -2. Oh, that's right. That's right. I flip-flopped that. Okay, hang on. That was the other class. Yep, we were on this one. You're right. Okay, so we got to actually finish graphing the first one. I don't have any more. You know how many I make? Exactly the same, the right amount. I'll get one printed for you. So guys, I'm going to plot these points, okay? I'm going to plot these points. I have the point -3, -6. Now, one thing I got to ask you guys, there's a point right here, okay? Here's my question, ready? Am I going to make it a dark circle or am I going to make it an open circle at -3? Dark, right? Because it says -3 is less than or equal to. All right, so that's going to be a nice dark circle. All right, then I got -2, -5. And then I got -1, -4. And then I got 0, 4. I got to ask you guys something kind of important. These are lines, right? Is there going to be a line that's going to connect? Watch. You guys watching? That's going to do this. Is that going to happen? Is there a line that does that? A linear equation that does that? No, because that's not what? It's not straight, right? It's not straight. It curves up, right? So we know that the piecewise function stopped at what value? It started at -3, and it went to what? It went to 0, but did it include 0? No, because where was 0 included? Down here, right? But here's where I'm going to lose somebody right away. I'm going to give you the hardest concept of the day already, right now. Okay? 0 is not included up here. But look at the yellow, right? I highlighted from -3 to 0, right? So is the number, like, is -½ included? Is that highlighted? Yeah, -½ right here, right? How about -1/4? -0.25, is that there? How about -0.1? How about -0.01? How about -0.001? So, like, where does it stop? It stops right at 0, but it's not going to include 0, right? So what would I typically put at 0 were this to be a number line? An open circle. So this is where I said I'm going to give you the hardest concept of the day right now. If I plug 0 into this, now I know I'm not supposed to, but if I were, what would I get? -3. So at -3, I'm going to put a point, but it's not going to be a point because it's going to be an open circle, right? Which means I'm going to get really close to this, but I'm not going to what? Get there, right? So I can get to -1/2. I can get to -1/4, a -10th, a -1,000th, a -1,000,000th, right? I can get right up next to it, but I can't actually get there, okay? Because at 0, what did I do? I'm going to give you a word. Ready? I went from here and I jumped up there. So as like just before I got to 0, I jumped and I went up to this one. Okay? And is 0 included in this one? Yes. So I'm going to put a dark circle. Right? So you really have to pay attention, guys, to the break in the domain, right? Where this happens. All right, then I have, I'm not going to plot a half, all right? So then I'm going to plot 2, 5. and I'm going to plot 4, 6. And I have a segment that goes through there now, right? With closed circles at the ends of each of those, right? So here's a quick little thing that you guys want to think about, right? Ready? Real important. If you look at this, this is going to tell you what you're going to have. You're going to have a closed circle at -3. You're going to have an open circle at 0. You're going to have a closed circle at 0, and you're going to have a closed circle at 4. And that's exactly what I have, right? Quick question. How do I know that this can't be a closed circle based on the picture? How do I know it can't be a closed circle? It's a tough question. How do I know that this circle right here has to be open? Why can't it be closed? Because if this one was shaded, that one must not be shaded, right? Because if they were both shaded, it wouldn't be a function because it wouldn't pass the vertical line test. Okay? So that's why one's shaded and one's not. Good? All right, down below. Here's what I want to do now. I want to actually take the picture and create the function. So I'm going to work backwards. Okay? How many pieces do I have? 3 pieces. Okay? So I'm going to discuss the green piece in the middle. Now it's green. I'm going to discuss the yellow piece to the left and the blue piece to the right. Okay? What I want to do first, guys, is I want to write down what each of these points are. Do you guys agree that this is the point negative 1, 2, 3, 4, 5, 6, 7, -8, -1, 2, 3, -8, -5? Go ahead and find the other 3. Okay, and if you look at the way that this piecewise function is written, what do? They give you the what, and then they tell you the where. They give you the what, they tell you the where. The what is the equation of the line segment, or the segment that's created by a line, right? The where are in terms of x's, right? So aren't these domain restrictions if they're in terms of x? Okay, so what I want to do down here is I first want to figure out what the domain is. What are the values of x for each of the pieces? Okay, so if you look at the yellow piece, does everybody agree that the yellow piece goes from -8 to -2? Okay, so the first domain restriction is going to start at -8 and go to -2. Guys, I'm going to put signs in here in a minute. Okay, inequality signs. I'm going to do that in a minute. Then I go from -2 to what? 3. Okay, so then I go from -2 to 3. All right, and then I go from 3 to 6. All right, and again, these are domains, right? So we're creating the where. All right, here's where you got to really listen. Ready? Is this a dark circle? Is it filled in? Okay, so I'm going to say less than or equal to. And then I go up to this point, and is this point filled in? Okay, so I'm going to go less than or equal to. But hang on a minute, ready? If I said less than or equal to, then what do I need to say here? Just less than. Because what's the point, guys? I already have the point considered here. It's already filled in here, right? Am I going to fill it in a second time? No. Now somebody, ready? if you're intellectually curious, then the question you should be asking yourself is, well, why is it filled in here and not here? Why couldn't it be the other way around? And the answer is it can be, right? If I wanted to say less than or equal to here, then I could have said what up here? Less than, right? So one of them is going to be equal to and the other one's not going to be. They just both what? Can't be equal to. Everybody okay with that? All right. So then I go to 3. All right. What do you want to put there? Is there a wrong answer to what you say right now? No. So what do you want to say? Less than? Great. So if I say less than, what do I have to say here? Less than or equal to. Why? Hey, guys, why would they both not be less than? Yes, it would. If they both said less than, it would be a function. But what would my graph look like? There'd be an open circle there. That's something called a hole in a graph. There'd be a hole in the graph, right? That would mean what? There's no value for -3, right? But that's not what we have. Okay, we definitely have a value there, right? 4. Okay, and then I go to the end, and is there a solid circle there? All right, so we're going to say equal to. All right, so there is our x values. Okay, here's the part that, guys, you have a couple of ways that you could finish this. Okay, here's one of them. Guys, these are 2 points, right? If you know 2 points, can you use 2 points to create the equation of a line? Well, let's see. If we go back to these lessons here, right? Where what did we do in this example right here, right? A line passes through the point 5, -2, and 20, 4. Find the slope, write the equation of a line. So could we do that? Absolutely, right? We have a method, okay? But here's the nice thing. The nice thing about what we have here is I have a picture, right? And when I have a picture, can I, if they ask for me, I'm on a, oh. All right, so everybody agrees my yellow line, I can create my equation easily, right? Okay. Now, if I have this picture here though, guys, like why don't we use our picture to help us do that? Okay. Can I easily use the picture to figure out the slope? What am I going to do? Count, right? So first of all, is this yellow line positively or negatively sloped? Okay. How do I get from one end to the other? Well, I go up 1, 2, 3, 4, 5, 6, 7, 8. I go up 9, and I go to the right 1, 2, 3, 4, 5, 6. So yellow line has a slope of 9/6. Do you guys want to reduce it? Sure. What do you want to make it? 3/2. All right. Now, to write the equation of a line, I know I need to do y equals mx plus b, right? Or I can use the point slope formula, but we're going to go right to the equation of the line, hopefully. So what is my equation? Well, it's 3/2 x. Now, what do I not have right now? A y-intercept. But guys, if I know the slope, can I just extend the line to figure out where it would cross, right? So if I go from, let me get rid of this here. If I go up 1, 2, 3, and to the right 2, where would this line cross? At 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. I think it's 7. Right? So I have 3/2 x plus 7. So I'm going to go over to my rule. And my first rule says what? 3/2 x plus 7. Everybody got that? Okay. What did I write? I wrote 4? What the heck? Plus 7. I said 4 too, right? All right. So be it. Now the green line. Does the green line have a slope? And the answer is yes. The slope is 0. When I have a horizontal line, all I got to do is say what the values are that are the same, right? So this was the point -2, 4. This is the point 3, 4. So this is the equation of a line, y equals 4. Yeah, right? It's 4 everywhere, isn't it? So this is 4. Take a second and find the equation of that blue line. And I don't care how you do it any way you want. All right, so for a slope, negative or positive? So again, I mean, if you're using, let's say you're sitting there and you're like, oh, I'm going to use the slope formula to get it. Fine, do that. I don't care, right? But I mean, be like smart about it. It's definitely a negative slope, right? So if you did the formula and you got a positive answer, you better go back and rethink it, right? So what did I do? I went down 1, 2, 3, 4, 5, down 6, to the right 3, down 6, right 3. So if I go down 6 to the right 3, I get that, right? So what's that give me? -2. All right, so I have -2x. And then, guys, what's the opposite of going down 6, right 3? Going up 6, left 3, or this would be the same as going down 2, right 1, and the opposite would be going up 2, left 1, right? So if I was to go up 2, left 1, up 2, left 1, okay, I'm going to actually go off the grid. Up 2, left 1, it's going to bring me up here, right? So where's that going to be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Now, guys, here's the thing. I showed you that way to get the equation of a line because I wanted to give you a different way to do it, right? You can always, always, always go back to the previous lesson, take the points, find the slope, use y minus y1 equals m times x minus x1 and get your equation, right? That is totally fine, okay? The same way yesterday, you can always swap x and y, right? Same idea, right? Multiple ways to do problems. All right, here we go. Consider the piecewise function, blah, 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 blah. Find the x-intercept of each algebraically. Guys, when you say x-intercept, what does that mean? Zeros, what's another word for that? Roots, right? And when I talk about x-intercepts or roots, that's where the y value equals 0, right? Always. So, what do I want to do? I want to take this equation and I want to figure out where the y value equals 0. Now, there are two possible areas where that can happen, right? I have the first rule. So I want to know what happens if I set that equation equal to 0. So if I set that equation equal to 0, I could add the x, right? And what would I get? X equals? Everybody? Oh, good God. 5 minus what number is 0? 5 minus 5. Absolutely not -5. Come on, guys. I mean, again, use that mathematical logic, guys. I know you're looking at this and you're like, okay, I'm supposed to move something to one side, divide. Guys, 5 minus what is 0? 5 minus 5 is 0, right? So I get x equals 5. That was rule number 1. All right, rule number 2. A half of x plus 2 equals 0. Let's solve that one. What do I got to do? Give me a step. Get the x by itself, so give me a step. Subtract the 2, yes. And of course, guys, you can do this with a calculator, but it says to do it algebraically. So, and then how do I get rid of the half? I multiply both sides by 2, right? And if I multiply both sides by 2, I get x equals -4. So here's the thing, guys. Here's the thing. How many answers do I think I have? I think I have 2 answers, right? But here's what I need to do. I got to ask myself, is the solution part of the domain for each piece? Is the solution part of the domain for each piece? Now, when I ask that question at first, if you're good with vocab, it makes sense. Is the solution part of the domain for each piece? Okay. If you're not great with vocab, let's go back to the previous page for a minute. Guys, this right here, this little thing right here, everybody sees it? That's the piece. That's a piece of. That's a piece of this equation, right? Everybody agrees with that? Does this go through the x-axis? Does this have a root right now? No. But if I graph the whole thing, would it? It would, right? It would eventually cross this. So if I set this equal to 0, is there going to be a value where it would be equal to 0? Of course there would be. But the problem is that value within what? This restriction, right? So here's what I mean by that. If I solved this, I would subtract 4, and then I would multiply by a half, and it would wind up being a solution of -8, okay? So I would have, would it be a solution of -8? Yes. Here's the issue though. Does -8, guys, fall in that boundary of numbers? No. So would it be a solution to that problem? No, right? And that's essentially what I'm asking you guys here, right? 5 is the answer to this, but does 5 fit into this rule? Is 5 less than 2? No. So this is not a solution to that problem. Okay? So now I go to the next rule, -4. Is -4 greater than or equal to 2? No, right? So guess what? That's not an answer either. So what does that tell me, guys? That tells me that this has no roots. There are no roots to the graph, right? So there are no roots. All right, so now let's take it and let's graph it, and let's make sure that there are no roots, okay? I think we did it right. Let's just check. So here's what I want to graph. I want to graph everywhere x is what? Less than 2 in yellow. All right. Isn't that all that? Less than what? Did it say 2 or -2? 2. All right, I got to keep going. All of that, right? And guys, watch what I'm even going to do. What's that mean? It's an arrow, right? So what does that mean? It's going to keep going that way, isn't it? Because it said x is less than 2. It didn't have a beginning. Keeps going. Then what do I want to graph? X is greater than or equal to 2. All right, so then I'm going to graph another piece all over here, like that, right? All right, so is there a chart? Do I have a chart here? Right? No, I mean, let's create a chart. So I'm going to have x values. Let's go like negative. These are lines, so I don't need a ton of points. -4, -3, -2, -1, 0, 1, 2, 3, 4. I guess I'm going to do a ton of points. 5 and 6. And then I have my 2 rules, right? So I have rule number 1. I have rule number 2. All right, so these are going to give me x's and y's, correct? So let's go to our first rule, and I got to plug in -4. What's 5 minus -4? Two negatives, same as 5 what? Plus 4, right? Okay, if I plug in -3, 5 minus -3, 8. 5 minus -2, 7. You guys smell that? It smells like burning, right? Guess what they just did? They just turned on the heat for the first time. That's why it smells like it's burning. That's great. 5 minus -1 is what? 6. 5 minus 0. 5 minus 1. 4. All right, now I get to this, guys. Ready? If I want to plug in 2, am I going to plug 2 into this first equation? Listen carefully. Am I going to plug 2 into the first equation? I am, but what's going to go there? An open circle, right? Because I can't actually be 2, but I want to get right next to it, so I want to know what I'm actually going to be at 2, right? So that's the part that was a little confusing. I'm still going to plug 2 in. It's going to tell me where to end with an open circle. So if I do 5 minus 2, I get 3, but this is going to be an open circle. All right, so if I plotted all those points, guys, what would I have? I would have -4, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's off the grid, so we'll go -3, 8. And at 2, 3, there's my what? There's my open circle, right? And look at what I'm doing now. Draw my line. Somebody yell it. What are we going to do? Put a arrow, right? Why do I need the arrow? Why do I need the arrow? Because it says x is less than 2. That means everything less than 2, correct? Yeah. All right. Now we're going to plug 2 into this. What's half of 2? Oh, go ahead. Question, Hanson? Do I have a Band-Aid? I don't. How did you injure yourself sitting there? Oh, wow. All right. Well, there's paper towels in the back if it's like seriously bleeding. You can like, if you hold pressure on something, it'll stop. Guys, half of 2. Plus 1, or plus 2. 3, all right? So now I'm over here. That's weird. We're going to talk about that. I'm not going to do half of 3. I'm going to do half of 4. So I'm going to skip. I'm going to skip 3. Half of 4 is 2, right? 2 plus 2 is 4. Half of 6 is 3 plus 2 is 5, right? So I just didn't plug in these ones because they'd give me halves. I don't want to deal with that. So I'm going to graph 2, 3. But hang on a minute. Is 2 part of this? So is it going to be an open or closed circle? Yeah, so here I'm going to have a closed. All right, so let's do that. I'm going to plot 2, 3. I'm going to plot 2. Uh-oh, hang on a minute. What's there? The open circle's there, right? So what do you guys think happens? No, you actually fill it in because what happens, guys, is a closed circle overtakes an open circle, right? If you put those two things on top of each other, what happens? Looks closed, right? And that's exactly what's happening here. Okay. So then we got 4, 4, and 6, 5. 4, 4, and we got 6, 5. 1, 2, 3, 4. Yep. And what do I put at the end of the graph? 0, right? So look at that graph. Did that graph cross the x-axis? No. So were there any roots? No, so our answer made sense, right? Does the graph contradict? No. The graph has no roots. All right, I guess we got another piece down here. It says, for this piecewise function, it says find the solutions where, okay, let's read this, guys. Find all solutions where f of x equals 1. What is f of x the same as? So where y equals 1, right? So basically, what am I saying? I'm saying, does this equation have any areas where y equals 1? So y would be the same as the f of x. So rule number 1 is 1 equal to negative 2x plus 10. Rule number 2 is 1 equal to 5x minus 1. Now what's going to happen here? I'm going to get two solutions, right? But then I got to determine if those two solutions fit within the domain of the rule, right? So subtract the 11. Oh, geez Louise. Subtract the 10. Get negative 9. Divide by negative 2. And that means I have a possible answer of 4.5. Maybe. We'll see. Add the 1. Divide by 5. And here I have a possible answer of 2/5. 2/5 is the same as 0.4. All right, so now we got to go to our rules, right? Now we got to go to our rules. So what does that first rule say? The first rule says that my answer has to be less than or equal to 0. So is 4.5 less than or equal to 0? No. So this is not a solution. All right, rule number 2. Is 0.4 greater than 0? Yes. And so this is the only answer to that problem, right? Because that piece fits, right? That rule fits within the domain. Is that okay, guys? Make sense? Anybody have a question on that? All right, so let's flip back to homework.